The KSP for silver phosphate is 1.8 times 10 to the negative 18. Calculate the molar solubility of silver phosphate. So first we see that KSP is given. This is very important for our problem. The first thing we should always do is look at what's given. So we know that our KSP is 1.8 times 10 to the negative 18. Therefore, it is best to look at the problem this way. KSP is equal to the concentration of X and the concentration of Y. Since we know that we are working with silver phosphate, we can actually set up a chemical equation. Ag3PO4 yields to 3Ag plus PO4 2 negative. So we can plug in our Ag and our PO4 here. This equation tells us that for every 1 mole of Ag3PO4, 3 moles of Ag will be ionized and 1 mole of PO4 will ionize. So these values tell us a lot of information for our problem. Since we already established that Ag and PO4 should go in these brackets, all we need to do is plug in what we know from our chemical equation. So Ag to the third power, because we decided that 3 moles of it will be ionized, and PO4 basically to the first power because only 1 will be ionized. So 1.8 times 10 to the negative 18, which is our KSP, should be equal to 3x to the third power times x. Now 1.8 times 10 to the negative 18 equals to 27 to the fourth power. Now all we have to do is solve because we have already gotten our x's out of our equation. In solving, we see that 1.8 times 10 to the negative 18 equal to 27 to the fourth power. We divide both sides by 27. This gives us 6.66 times 10 to the negative 20 is equal to x to the power of 4. We would square this to the fourth power, and that would give us our x. So 6.66 times 10 to the negative 20 squared to the fourth power would equal to x equals 1.6 times 10 to the negative 5.